Well, that's a cool intro. Okay, so today we'll be speaking about exception handling, error handling, and ideas that can be borrowed from functional languages to ease our working with exceptions and general error handling in Java. So for those who don't know me, my name is Grzegorz Piwowarek. Using local DSL, that would be something like Grigory, and I'm a committer at AssertJ and Waiver, or ex-Java slang library. I'm also a blogger at For Comprehension. I also help Eugene Paraschiv in running his site, Baldung. And most important, I'm a software developer at Tołk Software House in Warsaw, Poland. So, the topic for today is exceptions. Actually, it was like 20 years ago when people started first wondering about how useful exceptions are and what side effects, what caveats do they provide too. So, for example, Joel Spolsky, the guy behind Stack Overflow and Trello, wrote on his blog in 2003 a long blog post about his thoughts about exceptions. Those mostly revolved around the problems that he mentioned was that exceptions are mostly invisible in the source code. If you have runtime exceptions, if you look at your code, like high-level code, you don't see where it's being thrown. So this is a place where you can be pretty much surprised when exceptions can be thrown. Another very popular argument against exceptions is that they kind of behave like a go-tos, okay? People noticed that already in 60s that abrupt jumps from one part of the code to the other are not very good. Another thing is that, especially in functional programming, when we look at functions as methods, or at least this is how I often think about how I imagine code, I see code as kind of like a very complicated system of pipes. There are long pipes, short pipes, they are curvy, they connect to each other. And in functional programming, usually when we have a pipe, well, which is a method, something goes in, something goes out. And if you actually have a look at the exit point, if you pay attention all the time without blinking, and if you process everything that comes out, well, you can be pretty much sure that you are safe. But mechanisms for exceptions make all those pipes have like small holes, so they create opportunities for exceptions to leak out on different spots. Imagine working with queues, and imagine working with queues. Queues usually work like this, that you put stuff on one way and take on the other side. Imagine situations where you had elements just popping out from random like points in the queue. Another thing, another case against exceptions is that if you go async, they can be sometimes hard to track if you see stack traces flying in another threads. And in Java, it can be especially painful because we tend to abuse exceptions. We use exceptions in Java to model absence, to do control flow. Sometimes we use exceptions for some situations that are not really exceptional, that for some known business cases. Okay, imagine, well, when you go to a bus stop and bus arrives empty. Okay, is it really exceptional situation? Well, not very likely, but still, it's one of the business cases. It's not something where you panic and need to abrupt, like stop the control flow and collect the stack trace and so on and so on. Another thing is, another very common pattern is that if you have like control flow, the flow of your program, if it divides into two different paths, this is where you would often use, well, you might throw in some kind of exception to handle these situations. So there are some problems with exceptions, but there is one very interesting thing. They are actually quite more expensive to instantiate than any other purge. Do you have any idea why is that? Well, I have no idea what are you saying, but I assume that you were mentioning stack traces. Yes? Yes, okay. So yeah, that's the problem. When you instantiate a normal POJO, well, that's quite fast. But if you instantiate a POJO exception, this can be quite expensive to instantiate, because there is one method, fill in stack trace, that needs to pretty much traverse the stack and collect all information. So basically, I'm telling this is an interesting thing to remember. Well, but if you need to optimize your code, if you throw so many exceptions that this is a problem, it means that you have much bigger problems than the performance. So this is an excerpt from the article of Norman Meurer. This is the guy behind netty. And they needed to utilize a very interesting performance optimization when developing netty. So they were experimenting with instantiating throwables. And so they compared 3 different situations. First situation was, well, normal instantiating throwables at every situation. The first small optimization was caching of that exception. And the third, most interesting one, was generating a stackless static exception. So there was just one instance that would be used in some spot over and over. And I'm not sure if you can see actual numbers here, but if you look at instantiating throwables on the left side, there are actually bars. They are just super small. So the results in his particular benchmark was like below 0 operations per millisecond when instantiating in a loop. And when he was reusing a static stackless throwable, that was over like 60. So that's a huge difference in the performance. Of course, if you want to read about that, you have a link here to his article. Some of you might realize that JVM is somehow doing this kind of optimization underneath. There is something like an exception caching, but the problems with that, it works pretty much for known exceptions. And you can read about this on Heinz Kabut's blog over there. Of course, if you really want to optimize and get rid of stack traces, there's a flag, oming stack trace in fast throw. Well, but you probably don't want to do that with all your exceptions, well, by default. So over the years, people actually realized that the mechanism of exceptions creates, well, solves some problems, but creates a lot of antipatterns. And over the years, we managed to identify quite a lot of them. We won't be going through all of them right now because, well, some can be antipatterns, some not, depending on the particular context. But there is definitely quite a lot of possible vulnerabilities to think about. So for now, I'd like to have a look at how other languages dealt with such problems. So the very nice example is error handling in Go. Error handling in Go is, well, methods and how methods return values in Go is very interesting because they can always return more than one value. So every method can return either actual result or an error. This is kind of a pair. And what's super important, that those are not really exceptions. Exceptions are objects, those are normal values and can be treated as any other. So there's no change in the control flow when an error happens. You just continue, you check if it has an error, and continue further. Well, unfortunately, this is not that easy to, well, not that nice, not that concise to handle, because you still need to do a null check. But this is pretty much the price of, well, it's annoying, but this is the price for dealing it with such a way. It's the price of being slightly more sure about what's going on in your flow of your program. Well, but what's very interesting is that, of course, it's not like Go doesn't have, well, the mechanism for exceptions at all. It has something called the panic keyword, but in this case, when you are using that, it's reserved only for situations where, well, this is not just a business case where the bus arrives empty. It's a situation where there is an Armageddon, there's like the earth opens, there are meteorites falling from the earth, there are tornadoes and everything coming at the same time. So this is for real panic. You use that when you don't expect people from recover, when you don't expect people to actually recover from them. Well, there is an option actually for dealing with that, you can use deferred methods, but well, that's not what you would normally use. So before we go to the actual content, there will be some static typing propaganda. So we are on a Java JVM conference, so I hope I don't need to anyone like, I think we are all on the same page at that point, but let's still refresh some things and recall what type-driven development is about. So we all know what's the difference between static and dynamic typing. There are two camps. There's dynamic camp, static camp, and those the statically typed camp thinks that the other camp, those are just kids playing around, and though the dynamic camp thinks that static guys are just people that are not mature and can't use the freedom of lack of static typing. But there is one thing I'd like to point out in this discussion, especially that, for example, recently Uncle Bob wrote a blog post, which was a small rant about Swift and Kotlin, I think. He complained about basically static typiness of those languages. In his world, in his perfect world, there's no need for types because all types should be pretty much represented by a proper testing. But there's a problem with that. How much time do you need to run your tests? Especially if you are playing with, if you have a Spring application, multi-module Spring application, with persistence and other stuff. Well, in our projects, if we want to run an integration suite, it can last like 9 minutes. That's quite a lot. And if you look in some research papers about how much time people can concentrate on focus, that's measured in seconds and not in minutes. So basically, well, probably for me, if my tests run more than 10 seconds, I'm already on Facebook. And do you remember the basic principle of Agile? The basic principle about Agile is to have small development cycles and getting feedback as fast as possible. And this is actually a very cool thing about having stuff represented as types, because basically, if you code, you get your stuff read. You don't need to run your test. You have like test running continuously and giving feedback immediately. So this is a cool thing to remember about. And basically, if you are working with dynamically typed languages, it's very easy to leverage, well, the dynamicness of them. Because basically, well, you don't need to do anything. You don't write types. Well, and you just leverage, and this is it. You just benefit from that. But if you work with statically typed languages, if you want to leverage type-driven development, well, there needs to be some effort to be made. So the problem is that we often end up with situations like this. We don't want to make an effort. We use stringly typed development and represent everything as strings. And, well, this is, let's say, not an optimal usage of statically typed languages. If you wanted to really leverage this, you would provide an additional layer of security, of type safety, by leveraging types. And for example, here, look, you have name, surname. Of course, name is a string, surname is a string, but surnames usually, let's say, they start with capital letters. They don't contain numbers. So there's a possibility of utilizing a type that can validate that at some point and ensure that if you create a valid surname object, that one is a surname and not just a random string with something that's supposed to be a surname. And actually, since some time, Java started noticing that. So since Java 8, for example, we got an abstractions like optionals, stream, or computable features. The cool thing about optionals is that, well, you don't rely on nulls anymore, but you have a special type that can pretty much represent optionality. So the whole computational context is encapsulated within one class. So if something like this can be done with optionality, why not kind of try to apply and reuse the idea for different computational contexts? So this is where Scala comes in. Scala, for example, introduced the concept of a try, which is another container which is pretty much the same similar idea as optional. But this time, instead of encapsulating optionality, we encapsulate the whole context of like throwing exceptions, try catching them, and processing them. I know that it might look kind of scary, but it's much easier if you actually start using this. By the way, this is not like a core fundamentalist functional programming concept, because in like a fundamentalist functional programming, you don't have exceptions, you have only error objects. But since we are working with JVM and often we need to adapt to, well, reuse code that already throws in exceptions, this is where try comes in as like something that is a kind of a glue that allows us to encapsulate the exception handling. So if we were to switch from Scala to Java right now, well, if we wanted to implement this by ourselves, there are multiple options. You could, rely on abstract classes or interfaces. In Java slang or waiver, it was the decision was made to use interfaces, and unfortunately, we don't have a sealed keyword in Java. Sealed allows you to pretty much seal your type hierarchy. So if you, for example, have an interface, if you seal it, and so you can implement the same file to implementations, you seal it, you don't allow users to create their own implementations, which is slightly safer because here basically people, well, can re-implement this as they want. So, as I said, this is a glue. This is kind of a glue that allows us to encapsulate exception handling, well, the Java-like exception handling. So, if we were to implement this one, well, instantiate this, so we would need to, of course, do a try catch, check, well, just catch the exception, and now either return a success, which would hold the value inside, or the failure that would hold the exception inside. So in this case, we have two implementations, success and a failure. Success knows how to deal properly with the successful case, and failure knows how to deal with the case when the exception was thrown. So that's the main idea. And now, if you look at the try API, well, in Scala or Java, that contains a lot of very similar methods that you already know. Because if you have not been sleeping for past 3 years, you probably already know how to work with optionals or streams or computable futures. And if you played with other like functional languages, well, dozens of them since, well, like dozens of years, they all pretty much call same concepts kind of similarly. So you have maps, flat maps, filters, and this should sound very, very familiar. It's the same idea. So map allow you to pretty much declaratively do something on the value inside, and what the actual execution will be delegated to particular implementation. So from the high level point of view, you receive a try, but at this point you don't know if it's a success or a failure. But success has its own map implementation and failure has its own. So if you provide a function, success will just execute it on an underlying value, and failure will simply just skip this one and go forward to the chain. Same with other methods. So obviously, in most solutions like this, you will find kind of similar methods. So except for the core map, flat map filter, you have or else, where you can simply declaratively specify a default value that should be returned if something went wrong, or some on failure, on success method that allow you to perform side effects on those values. In this particular case, the very useful method would be to have something like recover, which allows you to detect situation where some exception was thrown. But maybe in this particular case, we know how to deal with that. Maybe if you try to parse a number from a string, maybe you know what to do if illegal number format exception gets thrown. Okay, so you can specify that, recover, and come back to the happy path. There's obviously another method like get, which allow you to pretty much very like abruptly take the value from the inside. But this, well, you shouldn't use that unless you know what you are doing, because this kind of strips you out of all this, all those benefits that those tools have. So let's have a look how could you work with try from the consumer side. So imagine a situation that you want to, well, get a list of URLs, well, from some search engine. So you can have a look at this at the method. The first one, it's a get search results. It throws an IO exception and return lists of addresses. So if you wanted to leverage try in such situation, we would remove the throws clause and package our result in a try object. And now, if you want to have a look at some two screens are here, so let me use my mouse. Maybe it will be easier. So if you, from the consumer side, now you get a get search results, you get a try, and now you can declaratively very easily specify what to do if something went wrong. In this case, we are simply logging some error. And if something went wrong, we are returning our default value. Because, for example, we are searching for JavaDay, and we know that in this case, well, there's at least one default address that we can fall back into. But those kind of tools are also very easy to use if you work from the producer side. So let's have a look at the implementation of the underlying implementation of the method shown on the previous slide. So in this case, as we can see here, we are having a look at two different search engines. We are relying on Google and on DuckDuckGo. Let's say we are using two different methods from two different SDKs, APIs, and they behave slightly differently. So we have the get from Google method that throws no such element exception and IO exception. As you can see here, this particular API uses no such element exception for representing absence. So in this particular case, well, we know what to do with it. If there's an absence, we can pretty much convert that exception to the empty list. And this is what we are doing in the implementation, in the first recover call. And well, let's say that by having a look at the documentation, we realize that there is another exception, let's say NSA forbidden exception. Well, in this case, we probably want to just ignore some of those results and return an empty list, because this is eventually what we care about from the consumer side. And again, if that didn't work, we can fall back to another try, which is in this case DuckDuckGo, and so on and so on. So it's very easy, composable, and very readable after some time when you get used to this. Because Java developers for dozens of years were trained to read and write imperative code, which is objectively harder to read than declarative one. Well, I've been learning Polish my whole life, and it's very intuitive for me. But I realized that it's, well, if you look at the language difficulty scale, it's probably not the easiest one in the world. But for example, Italian is way more easier. But for me, Italian is very hard to get. But well, I was trained to read and speak Polish, right? So after some time of playing with that, it becomes supernatural, and actually it feels very weird to come back to doing this the imperative way. The one thing, very important thing to remember about here is that in some cases when we compose those solutions, we might end up in when we have nested objects. So here, as you can see, we are calling an open stream method when we get results, but we want to, let's say, open the stream, and well, it throws an exception. So the natural thing to do would be to wrap it in another try. But now, if we map it to another try, we end up with a result that's try input stream. So you might think that this is something that is extra safety, okay? Well, if try is safe, and if I put my try in another try, that's super safe, okay? Let's do this more, try. No, that actually doesn't give us anything. That's actually becomes quite cumbersome to keep repackaging those packages with values. So the important thing to remember about that for such situations there is a special version of map method called Floodmap. And in functional programming languages, if you have sealed hierarchies, there's another way of handling this by using pattern matching. In waiver, well, it's doable, but it doesn't look very good, and honestly, it's quite hard to write it because the whole thing stops being read in your IDE after you put last comma. So the IDE is not helping them to be very proficient in writing this to making it good. But there is a good news, because if you are tracking the Java news, you know that probably in Java 18.3 in March, there will be pattern matching coming to Java. If not 18.3, then 18.9. I'm not really sure. I think yesterday I heard that they changed the naming scheme again, and it will be Java 10 and not Java 18.3. Anyway, this should be soon coming to Java. So basically Java is slowly so at the beginning Java was rejecting functional ideas, but now they are slowly pulling good stuff from other languages. That's quite interesting where it might go. But this was the case when we were dealing with, well, exceptions, actual exception handling in Java. But if we really wanted to abandon exception handling and leverage error objects, well, for example, we might use tuples. But there is one problem with them. Okay, we use tuples for representing, well, for returning two values from functions, and then after each call we need to do two null checks. Well, which is, well, double annoying as in Go. In Go there would be just one case, one null check to do. Here there are two. The problem with that tuples are usually designed to hold non-optional elements, non-nullable values. So this is not optimal and feels very, very awkward. So there is another idea. This time it's a core functional programming idea that can be utilized here. And this is either. Either is a very general purpose class that allows you to store either one object of one type or of the other. Well, it might look scary, but the idea is pretty simple. If you think about an optional is this kind of an either too. It's something that calls either your desired value or something else that represents absent case. Same with a try. It's either your result or some exception. And in this case, you have either, which is either whatever you want, either whatever you want. But there is a very important thing to remember about. With optionals, tries, and other tools like this, you are usually biased towards one of those two options. In optional, you are kind of biased towards case where the value is present. In try, you are biased towards the case when everything went okay. But in either, there is no such distinction. So it's up to you to specify at some point which value you care about. If you care more about left side or the right side. And actually, in Scala, it's not like this anymore. Since I don't remember which version, it's biased toward right side. And this is basically a very popular convention, that the side on the right is the good one, and on the left you have an exception. So let's have a look how this could look like in Java. So again, we don't have sealed keywords, so we need to play with abstract classes or interfaces for representing two cases, lefts and rights. And instantiation is as easy as creating left or the right side. So we're using factory methods. Nothing difficult about this. And again, if you look at the whole API, it should be super familiar because it's the same canon as optional streams and other stuff. But there is one very important thing to remember about. Again, eithers are not biased. Well, it can vary in different languages, but the general idea is unbiased. So something like projections exist. You can make a left projection or a right projection. And if you make a left projection, the projection will behave like it's left biased. And if you do the right one, it will behave like it's right biased. So if you, in this particular case, you care about the happy path or the left side, you make a left projection, and then whenever you call maps, filters, and so on, they will do something with that if this is the left side. If you made the right projection, well, if you may, and then you call maps, filters on other APIs, this will do something only if it's right side and ignore if you got the left type. So unfortunately, the API is not that cool as in try, but in try on optionals, we already know the context. In either, you don't have a context, you have only two values. But it's still nice, still easy for error handling. And again, you have something like get left, get right, which you shouldn't normally use unless you really know what you are doing, because it strips you from all this additional type safety. And let's have a look at how this could potentially look like in Java. So in Scala, well, in this case, you can construct your own tailor-made error object if you want to return it from a method. So in Scala, you will just write one line. That's just a case class and some properties inside. But unfortunately, this is, and you see, it's short, concise, and highly disapproved by Yegor Bugayenko. So if you have a look at what happens, well, unfortunately in Java, it looks like this. It does exactly the same stuff you had in Scala, but I think in next Java we are getting value classes, so that should be as concise as this and as performant as primitives. That's super cool. But you won't be able to synchronize on those values. So now, let's have a look at how working with either looks like. So let's have a look again at the first example of fetching search results, well, from some search engines. We already have a try and of list of URLs, but this is a situation where we handle exceptions. But in this case, if we want to leverage either, we create a type, and this time we return either fetch error and list URLs. So now, if you want to play with that, if you call get search results, well, if you want to have a look at the actual result on the right side, you make a right projection and then leverage the declarative API for handling this situation. If you cared about the exceptions, you do the left projections and then process it as you want. Of course, we are doing two unnecessary calls here, but usually you would want to, of course, reuse the same result for separate scenarios. Another interesting case, another interesting usage for eithers is modeling of alternative paths. So, for example, well, here there's no exceptions, okay, no errors. Imagine a DNS server. Well, imagine requesting a complete resolution of an address from a DNS server. Well, they internally work like this, that they just keep asking other DNSs for the remainders of the actual address. So in this case, if you have some internal method like resolve, it might either give you a complete result or, for example, give you an address of another DNS. And actually, this is quite used in practice, because if you have a look at what's going on, for example, in Scala source code, you will see that, for example, the tailrec leverages either for representing tail recursive computations. So I think it's slightly too wide, but I think everything is in the picture. So in this case, you have an either. You either get a result or either something, well, another tail recursive call. So yeah, this is actually used. So another idea is that often we leverage, well, at least in Java, often the exceptions are used for leveraging or managing absence. So, for example, if you have a look at some repository methods like find one, they would often throw no such element exception instead of, well, returning, well, just an empty value and letting people do whatever they want with them. Same, for example, with multiple parsers. If you parse a string to an integer, often those messages are not very valuable and don't tell you what went wrong. So in this case, it's as good as giving you nothing. So why not just give you something that's optional? Well, and we have a tool for that. So we have an optional. So in some cases, why not totally just ignore exception handling and ignore messages that don't give us, well, much information? Why give us messages they don't reduce entropy too much? Well, you can still wrap it in an optional. And this is super cool, because if you throw an exception, you kind of impose some way of dealing with the situation by consumers of your API. And if you give someone an optional, well, they still might throw an exception. They might, well, do something with that, or they might totally ignore this and make .get call. So that's slightly better. As a user, I usually prefer to have a choice. But the interesting part is if you go on GitHub and try to do very naive searches, you can see that a lot of, well, there's a lot of constructs like throw no such element exceptions or not found exceptions. And keep in mind that those are very naive searches using like complete strings, and you have like almost 600K cases where this is being done. So as you can see, there's quite a huge abuse generally going on in Java code when it comes to exceptions. But I hope this idea will be helpful for you, will help you write better code. So there's a problem. What if your language doesn't support that? Well, switch your language. That's not so easy, right? You have a corporate client, you have a bank that's running Java 1.2, and you go there and say, dude, I'm writing Rust, I'm writing Kotlin now. No, it doesn't work like this. Well, you can build it yourself, which is, well, doable, but you probably wouldn't want to do that. However, I remember we used to implement try at the beginning of Java 8 when there was no try in Java slang. But the most reasonable solution is probably use waiver and Java slang, because, well, that's probably the only solution that gives the one complete solution that gives you functional tools. For now, it's like it has everything inside. It has functional interfaces, it has functional control structures like try, iders, and so on. It has persistent collections API, but now I think in a week or two there'll be a new version released which will be kind of sliced into different projects. So you don't need to pull everything into your projects. If you don't care about persistent collections, ignore them and just take the functional control structures. If you don't care about functional control structures, take collections and so on. So there will be a lot of changes, positive ones, and I believe everyone could benefit from that. Another interesting idea is the JCP, Java Community Process. So pretty much, more or less, most of people can actually somehow contribute to the development of Java. And for example, this is how lambdas kind of were brought to Java, and same with Yoda time, which is now Java time. So definitely there are different levels of memberships. I mean, if I think that the most basic one allows you to just review JSRs, and the ultimate one allows you to do everything. Not sure how do you progress from them, but still there is some way of influencing this. So if you want to see more good stuff brought to Java, put some pressure on it, and let's hope for the best. So the key takeaways for today would be that exceptions are not so bad. Exceptions work quite cool in Java, but in situations where you pretty much don't expect people to recover from them. If you still work with code that throws exceptions and you want to try to leverage functional concepts for dealing with them, you can use tries as a form of a glue between functional approach and like the Java-like approach. If you are dealing with optionality, well, maybe it's worth reconsidering and abandoning throwing exceptions and simply returning an option, allowing users to do whatever they want with them. And Either is a very generic purpose tool that can leverage nice error handling using error objects and sometimes handling alternate paths in your logic. Also, waiver is probably the new Guava. So waiver, I think, is one of the two first three things that I add to any new Java project. One is AssertJ, one is Lombok, and the third one is waiver. I think this is absolute necessity for like modern Java development now. So I hope everything was. I hope I shed some new lights about some things that can be done in Java. And thank you very much. And awaiting questions.
Hi, could I have a question? I have a question regarding the real practice of, for example, not using exceptions and using, for example, optionals. Do you know if there are any real business projects that try to use a paradigm of using optionals instead of throwing exceptions?
Well, of course, optionals are actually a very easy case, and it's very easy to convince people to do that because, well, it's not a very advanced concept. Okay, if you have an unnecessary exception, you get rid of it, replace it with optional. And yes, we've been doing that since a few years for now, and I don't see problems with that. The problem I see is if you use eithers and tries, usually you need to convince often your peers to do that. That can be problematic. I don't see problems in like in implementations, even in corporate projects, but the problems mostly I faced is like convincing people to do that this is actually easier than doing it the old school way.
Okay, since you have some practice, do you have some measuring values with, does it improve the performance or does it reduce the time of test executions, such at least this easy approach using optionals instead of
Okay, it doesn't, well, actually when you go for this, at this high level of programming, I don't think you should worry about performance, okay? Because whenever you throw an exception, if you throw a single exception, even if this is costly, well, it's not that painful, okay? It's a problem if you do that in a loop. So of course, instead of instantiating an exception, you instantiate a simple object. That, in the case of optional, it will be slightly faster than instantiating a normal exception, but this is not something that I would worry about at this problem. Because, well, usually if you do this, at least in most of my projects, the bottlenecks were somewhere else. So, of course, those solutions are high-level solutions. And I honestly treat mutability and going low level as a form of optimization. So at this point, don't worry about this. It will be slightly faster, but unnoticeably faster. So this is not something that I would consider if I was choosing this approach.
Just a quick implementation question. If you are mapping a try and your mapping function throws an exception, it catches it, I think, yeah? Mapping a successful try and mapping function throws an exception, then try encapsulates this runtime exception that it was thrown, yeah?
No. No. This
so
doesn't.
It just rethrows to your code, yeah?
Yes, you are responsible for doing this on your own. Actually, for example, this is interesting thing because in functional programming languages or in Scala, even in optionals, if you return a null from a mapping function in an option, you get an option from null. Okay, so those languages those solutions leave this responsibility to you to do this the proper way, and it's the same was done on the presentation. Look, there was a method that throws an exception, and we need to handle it by ourselves. The interesting part is that optionals in Java, they went slightly more in terms of handling optionality. In Java, if you have an optional, it converts it to an empty optional. But yeah, in those cases, you need to handle this by yourself.
You told you use Lombok in some of your projects. Do you use Nicky Strauss annotation? And if so, where are the good usages for it?
Stinky throws. For those who don't know, the sneaky throws concept is an idea of pretty much tricking compiler that checked exception is an unchecked ones. Not really. I don't really use that in Lombok. At some point, I've been using this in Waiver. In Waiver, there were some shortcuts for sneaky throws. Actually, I have a big article on my blog about this. But usually, I don't use it. I try to avoid checked exceptions as much as possible. So there's no need for sneaky throwing anything if those are classes that I control. But generally, the concept is useful for when dealing with lambdas and throw and checked exceptions. Because as you know, in Java it can be super painful because all those functional interfaces, they don't define any throwing any checked exceptions. So everything you need to try catch inside, even if you are 100% sure that nothing is get thrown there. So no, I don't use it. I try to not use checked exceptions, and well, I guess this answers your questions.
Yeah. Thank you.
Thank you for your talk. I have a question. I didn't get exactly the concept of either. So you can choose left or right pass, but why we just cannot return some box with two types and check type?
I think that this thing you are saying is exactly that what we did here. You have a tuple with person or error objects with two things, and if you just return an object containing two things, well, you need to check those cases manually. There's a lot of imperativeness involved in here. But if you have an either, you have a box that provides you with also a box that has one or the other and provides you with a fluent API for dealing with that. So everything is encapsulated, and that's all. That's exactly it's
Pattern matching. If you can match just two types and go either one or either second.
Can you speak close to the microphone because the music is kind of.
I mean pattern matching. If you can match the type and just move one way or a second way, I don't get how you can choose go left or right. You just choosing it. How you can check how.
I mean internally, or
no, consumer how he knows what path he should go, left or right.
projections. By doing projections, you need to prepare for both cases. Okay, so you do left projection and then handle success, and then do a right one and handle the other option. This is where you pick which part of the either you are working on.
So if left part is not work properly, you go in the right way, yeah?
Yes.
Thank you.
Okay, thank you.